Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, good student.
Waalaikumsalam warahmatullahi wabarakatuh. Good
Waalaikumsalam
morning, Miss.
Waalaikumsalam. Good morning, ma'am.
Okay, how are you today?
I'm good, thanks. How about you?
Okay, I'm good. Thank you, Kiki, for asking. So please, if you don't have any trouble with your connection, let's start the class with open your cam. Okay. Wow, nice, Jonathan. Hello, Ilzam. Okay, before we're gonna start, I will check your attendance first. Okay. Jonathan Reynaldo.
Present, ma'am.
Okay. Jane.
Present, Miss.
Okay. Kiki Kurniawan.
Present, ma'am.
Okay. Nilzam Fadlah Winarno.
Present.
Okay. Safana Mira.
Present.
Okay. Fania.
Present, Miss.
Okay. Finalia.
Present, Miss.
Okay. Alhamdulillah. So all of you is attend for today's meeting. Okay, so today we're gonna learn about the energy. Okay, so after this class, you will be able to analyze the concept of energy after the conduct experiment about the energy simulation, and then you'll be able to explain the relationship between the energy potential and energy kinetic, and then you will be able to mention at least 3 examples of energy in daily life after watching a video, and then you'll be able to calculate the amount of energy when an object moves at certain height after doing discussion, and then you can explain the form of energy change in everyday life after doing discussion, and then the student will be able to present the result of the experiment about the skate simulation. Okay, students, so are you ready to learn about the energy today?
I'm ready, Miss.
Ready, Miss.
Yes.
Actually, I'm not ready because I'm not good at physics. I'm afraid that I'll get the questions wrong.
Oh, that's very okay, Jonathan. Don't be afraid if you made a mistake because we are here to learn. And then don't be hesitant to asking a question also if you don't understand or if you don't get it the material, because learn is the process. As long as you are still curious and want to learn, you will master at this material. Okay, Jonathan, so please be ready. Okay, now I have a question to all of you. Have you ever ride a bicycle?
Yes, Miss.
Yes.
Yes.
Yes, okay. And why do you think you can ride the bicycle? Or
Because
how
I always practice more and more.
Okay, Valenza. Okay, sorry, Jane. You said you always practice more and more. Okay, another student?
Because I ride it.
Because you ride it. Okay, Kiki. Another else?
Because I'm giving the bicycle energy.
Okay, that's very good, Johnny. Yeah, that's true because you give the energy to the bicycle. And then can you mention the other example of energy that we give in our daily life? Because Johnny already said about you give the energy to ride a bicycle. Another else? Can you give the example?
Maybe walking, Miss.
Walking, that's correct, Finalia. Okay. So after this, I will give you the example for the energy based on the video. So please watch the video carefully, okay? Okay, so student, after watch the video, what you learn from that video? Or what did you get from that video?
Oh, may I, Miss?
Sure, Finalia.
Best what I get from the video is the potential energy related to position, and while kinetic energy related to motion, Miss.
Yes, that's correct, Finalia. Thank you. And then the other student, please.
To add the formula for potential energy, Miss, it's M times G times H.
Okay, that's correct, Johnny. That's very cool. Okay, and then the other student wants to add?
The energy cannot be created and cannot be destroyed.
Yes, that's correct, Nilzam. Thank you. Okay, that's all. Maybe after this, I will divide you into 2 groups, consist of 3 or 4 members, and then you will experiment with the PET simulation in the breakout room session. And then I will give you the worksheet. I will give the link in the chat box. And then after that, you have time for more or less is 1 hour to discuss, and then back to main room to present the result of the discussion. Okay, so if you have difficulties, you may ask the host to come into your room and I will come to your room, okay? So I will make a breakout room.
And I will explain briefly about the PET simulation itself. So the first thing I want to explain to you about the feature in the PET itself. The first one is the pie chart. If you click here, the pie chart, you can determine the energy itself, what kinetic, potential, and thermal energy. But in today's class, we don't use thermal energy. And if you click the bar graph, here's as the reminder of the different types of the energy. And as you can see here, you can see the amount of the energy itself. And then for the grid, if you click the grid, you can see in detail the height of the object. And then if you click speed, here you can see the speed, the minimum and the maximum speed of the object. And then you can also adjust the mass of the object, what you want to small and make it larger. And also you can choose the track. This is for the U track. This is the line track. And this is for the W track. And if you feel the object move too fast, you can change into the slow motion, as you can see here. Okay, and then if you want to restart everything, just click here, restart the scatter. Okay, so do you have any questions, student?
Okay, I already opened the breakout room, so you may join to the breakout room from group 1 and group 2. Okay. Okay, see you in the main room session later. Goodbye, student.
I think you can checklist the pie chart and the bar graph so we can see which kinetic and which is potential and which is thermal.
Oh my God. Wait a second.
I think the potential energy has the highest percentage of something.
Oh yeah.
I don't know. What about the others?
If the height, the higher the height, the greater the potential energy. And once the skateboarder goes down, the kinetic energy increases. But we don't see any changes in the thermal energy here. So kinetic energy is related to velocity, I think.
Yeah.
I think it's not M times E, right? It's just an abbreviation. ME stands for mechanical energy, and KE is for
Yeah.
That's not
okay,
times.
Okay. Thank you.
Okay, hello everyone. So how was the breakout room session?
It was
fun,
confusing,
Miss.
Miss.
Okay, interesting, fun. Okay, and then the other student, how was your feeling in the breakout room session?
It was pretty challenging, Miss.
Really challenging. Okay, that's very okay, Johnny. Okay, after this, we're gonna discuss about your results. So both of you, or two group of you, need to present the result of discussion. Okay.
Could you see my screen, Miss?
Yeah, sure. Thank you, Safa.
All right. So we're from group 2, and this is our discussion result. Actually, the answer is pretty similar with the group 1. So the ME is stands for mechanical energy, and KE stands for kinetic, and PE stands for potential. So it's stated in the video before. And for the formula is also, we saw that in the video. So the formula of mechanical energy is ME equals to KE plus E for potential energy. And the formula for potential energy is mass times gravitational force times height. And for the kinetic energy, it's half of mass times 2 volume quadrat. And the last is there is in the first picture there is a position movement. So we guess it's potential energy, and for the second one is there is a motion, so we guess it as kinetic energy, and for the third one is there is a combination for motion and position, so we guess it as mechanical energy.
Okay, thank you, Finalia, for the explanation. And then I want to clarify about the formula of the kinetic energy is 1/2 times mass times velocity times square. So the V is not a volume, it is a velocity. Okay, group 2.
All right, Miss. I'm sorry for my mistake.
Okay, that's very okay. Thank you so much, group 2, for the explanation. You may stop the screen. Okay, so do you have any questions, student?
Okay. May I, Miss?
Oh, sure, Jen.
So I just curious, from the formula, we know that gravity is 9.8 meter per second square, but why the value of gravity is 9.8 meter per second square, Miss? So that's my question. Thank you.
Okay, thank you, Jen. That's a very great question. The other student wants to try to answer first? No? Okay, so, okay, actually, the value of the gravity is 9.8 meter per second times square, but sometimes if you solve the equation, you can use 10 meter per second times square as a nominal or surrounding. And the reason why it should be noted as the strength of a gravity is not a constant. As you get farther from the center of the earth, gravity gets weaker, and it is not even a constant at the surface. So as it varies from 9.83 at the poles to 9.78 at the equator. So that is why we use the average value of 9.8, or sometimes we use it at 9.81. So do you understand, Jane?
Yes, Miss, that's clear. Thank you.
Okay, thank you so much, Jane, for the question. And then, so we are at the end of our today lesson. Anyone wants to try to conclude our lesson today?
May I, Miss?
Yeah, sure, Milzam, you can.
Okay, so the energy cannot be destroyed and it cannot be created. It can be transformed into the other energy. And there are 3 types of energy, which is potential energy, kinetic energy, and mechanical energy. They have relationship, which is they have the ability to transform into each other.
Yes, that's very great answer for Milzam. That's conclude all of our lesson today. I will add a little bit about the conclusion. So because the potential energy, you need to remember is the position relative, and kinetic energy is motion relative. So the potential energy transform into kinetic energy and it's back again and vice versa. So that's all for material today. I give both of the group is appreciation because you did a great job for this class and at discussion. Congratulations, students. Please keep your spirit up and your curiosity up. And don't forget to put the worksheet on the Google Classroom. And for next week, we're gonna learn about the food energy and specifically about the biological molecule. And let's end up this class with Hamdallah. Alhamdulillahirabbil alamin. Thank you so much for today. See you next week. Thank you so much.
Thank you. Bye.
Thank you, Miss.
Thank you.
Thank you, Miss.